Okay, let's talk about a really common problem in AI. Imagine a huge old library packed with experts, right? Now, what if every time someone whispered a question at the front desk, every single expert dropped what they were doing to listen in? It'd be chaos. Well, that's the kind of AI traffic jam we're going to unpack today by following two engineers who figured out a brilliant fix. They designed a system that's not just about thinking fast, but about knowing who should be doing the thinking in the first place. All right, so to really get this, let's meet Timothy. He's a junior engineer, and he's built this amazing team of specialized AIs. But instead of everything running smoothly, he's got this massive bottleneck, this huge traffic jam happening right at the front door of his system. And Timothy just nails the problem with this quote. He's got these brilliant specialists ready to go, but every single question gets shouted out to all of them at once. It's exactly like he says, a waste of energy, just total inefficient chaos. You know, there's actually a name for this kind of mess. It's a hidden cost that can absolutely cripple a complex system. Timothy's senior colleague, Margaret, she calls it the coordination tax. It's basically the price you pay for not having a smart traffic controller managing the flow. But this is where Margaret steps in. She's got a plan. She sees a way to get rid of this tax completely by adding a new piece to the puzzle, a super high-speed switch that sits right at the front of the system, and she calls it the navigator. So this is a total game changer, right? They're moving from just broadcasting, shouting at everyone, to what Margaret calls precision switching. No more noise. The navigator, which you could also call a semantic router, is going to take each question and send it directly to the one expert that's perfect for the job. Okay, but wait a second. This brings up a really interesting problem, doesn't it? How can this navigator direct traffic if it has to stop and read every single car's destination? I mean, if it had to read and understand the entire user question, it would just become a new bottleneck itself. And yep, that's the million-dollar question Timothy has. How on earth can it know what the user wants without reading the whole thing? Well, the answer Margaret gives is fascinating. It's not about reading. It's about feeling the shape of the question. Well, the secret weapon here is this tiny, super fast AI called an embedding model. Think of it less like a reader and more like a GPS for ideas. Its only job is to take a sentence and, in a flash, turn it into a set of mathematical coordinates. It's not trying to understand it, just find its exact location on a map. So it takes those coordinates and bam, it plots them on this huge 3D map of ideas called latent space. Now, what's cool about this map is that similar ideas naturally group together, kind of like neighborhoods in a city. So if a question's coordinates land smack in the middle of the translation neighborhood, the router knows instantly, send this to the translation expert. And here's the kicker, the speed. This whole thing, finding the coordinate, plotting it on the map, and flipping the switch to the right expert, it all happens in less than 10 milliseconds. I mean, that's insane. That's faster than a big AI model can even start thinking about its first word. Okay, so that works great for simple questions. But, you know, life is messy. What happens when a question is a bit tricky, when it touches on more than one area of expertise? And Timothy's right on it. He asks, okay, but what about those tricky questions? The ones that are kind of half research, half translation. You know, like if a user asks for a translation of some obscure historical document, that's two different jobs right there. So for that, the router has another trick up its sleeve. It's a technique called zero-shot classification. Basically, you give it a little cheat sheet that describes what each specialist is good at. When a complicated question comes in, it just does a super fast logical check against that sheet. It can even be smart enough to split the task, sending the history part to the researcher and the language part to the translator. It's like Margaret said, it becomes a traffic controller with a PhD. All right, but what if even this super smart traffic controller gets stumped? You know, what if it looks at a question and just isn't sure where it should go? Well, it doesn't guess. Instead, it uses a really smart safety net called escalation logic. And this, right here, is where the system's genius really shines. It doesn't waste time or energy guessing. It just escalates the problem up to the lead planner. This is their big, powerful, do-anything model. It's the most expensive one to run, so the whole point is to only wake that genius up when you really need it, saving all that heavy-duty thinking for only the absolute toughest problems. So, they've done it. The smart router is in place. The escalation logic is working. What's the verdict? How did this actually change the day-to-day flow in their digital library? The results were honestly staggering. We're talking an incredible 90% of all incoming requests were now instantly and, more importantly, correctly sent to the right little specialist model. the traffic jam, it just vanished.
And this chart just lays it all out, doesn't it? That big blue slice, 90% of the workload, is now handled by those small, fast specialists. And that powerhouse, the lead planner, it's basically kept in a deep sleep, only getting woken up for those truly tough 10% of cases that really need its brainpower.
I mean, the whole feel of this system just changed. It went from clunky and chaotic to totally fluid and organized. That lag that users used to feel, pretty much gone. Zero. The chaos was just replaced by this quiet, efficient precision. And it really all boils down to what Margaret figured out. This is the big idea here. Real efficiency in these complex AI systems isn't just about raw processing speed. It's about the intelligence to know exactly which part of the system needs to be thinking at any given moment. So what they built here is way more than just a fix for their library. It's a blueprint for building smarter, more efficient AI systems everywhere. And it leaves you wondering, right? What's the next big coordination task out there that AI is going to have to solve?